Okay, Jingquan is not joining us today. Ashton, do you have any questions from last week? No? Okay, so that means I can ask you any question. Can't think of any. Oh, so check your notes, see whether you have anything to ask or not. Okay, you better keep a consistent notebook from now onwards. What? Where's the notebook on me? Oh, is it? Okay. Tell me, what's the difference between fractional distillation and simple distillation? Solid liquid mixture. More specifically, what kind of solid liquid mixture? Okay, use the word solution. Now, just now you mentioned about the two miscible liquids. What other condition is necessary for them to be separated? Yes, good. Okay, Ashton, I already mentioned two separation techniques. Come give me at least two more. Yeah.
Separation, crystallization.
Okay, great. What's the difference between the two?
Crystallization is using
Any difference? I mean, any one difference?
separate material from a solution that is not non-heat sensitive.
Okay, good.
And crystallization is trying to separate material from a solution that is heat sensitive.
Okay, good. At least you remember that important point. But let's instead of using the word material, what word could you have used? Okay, use the proper term. Can. But anyway, just to reiterate, for his two methods, your original mixture is actually a solution. Okay, just like for you, simple distillation, it starts with a solution. Actually, the other fractional distillation is also a solution. So guys, just be a bit clear. Okay, just be a bit mindful. There are solutions.
Yeah, two types of solution.
For now. Yeah, for now. So it can be a liquid dissolved in another liquid. Can still counted as solution. Oh, but obviously. Take note of the word miscible. It means it can be mixed, it can be dissolved. Yeah, you see this sooner or later. Okay, so for now, this two types. Yes. Of course, there are other types. Let me introduce one more type to you. You may see this sooner or later. And important, of course.
Is this first time we get one, I'll be done with them. So you, at the end, I can never do these numbers, and then you like, that one too. Because the
Really, if you are a
let's say,
Is oxygen equal to water?
or not, good question though. If you are a teacher, you need that, you need that.
Oh, they call it, not oxygen.
Ah, yes, right. So you already have the term there.
It's nothing right now. 1, 3.
Without dissolving in water, all aquatic animals will die. Or at least most of them. Now, the other example is not as uncommon as you think. Surely you have drunk that beverage called Coke.
Isn't it carbon dioxide?
Oh, yeah. Yeah. So carbon dioxide is dissolved in Coke. Right? Coca-Cola, Pepsi-Cola, the CO2 that's dissolved inside. I'm sure you tried drinking Coke without the CO2, right? After you leave it in the open for many hours.
Yeah, I found that before.
Yeah, it's definitely
nice.
not nice. Okay, so keep that in mind. It's not solid in liquid only. It's can be other things in liquid. And other, okay, for now, 3 is enough. How many are? Not that many, maybe about 6, 7.
Ten.
Don't worry. You worry when the time comes.
Give me that then.
No, still 6 or 7. Okay, what else was I going to say? Oh, yes. The other thing. Come, Ashton, what are the 3?
What? Stop atomic particles is around.
Small
Wait, can you tell me what the other?
small particles in an atom.
Oh, is it the mixture and
Mixture? No,
mixture and thing?
no. It's not. It's not linked to mixture. Come in.
Oh, those.
Come in. Relative mass.
Oh, 1/4.
There's a relative mass?
Oh, yes, there is.
I got that question wrong, because I forgot.
Oh, you forgot. Remember. Remember.
I didn't even know there was a relative mass kind of a thing.
Yes, there is, Ashton. This is super important. It will come up. Definitely.
Oh, the neutrons just one, right?
Yeah.
So neutrons are neutrally charged and protons are positively charged, right?
Yes, good. That's the other part.
Wait, so what is it? So relative mass is like, well, what is the relative mass about? Like, what is the point of relative mass of some capacity of the
How do you get the numbers? Look at sodium. What's the larger number? 23, yeah? And that's the mass number. How do you get the mass number? Uh-huh. Go on, go. Okay, come. Let's ask me. Sodium. How many protons and neutrons does it have? Good.
Electron, 11, neutron, 12.
Ah,
How you know? How you know?
Okay, come tell us. Wait, how do you know?
The one at the top is proton and electron are same. Then neutron is just the relative atomic mass.
You see the smaller number, Ashton?
Yeah,
What's the number?
11.
So I put 11 here.
Okay,
That represents the number of protons.
okay.
And if this is uncharged,
So the number of proton and electrons are always the same.
not always provided
It's not.
Provided what?
One is not a prime.
provided they are these two numbers are the same provided I write for you. Yeah, provided the whole atom is neutral.
So when can you identify that the atom is neutrally charged?
If the question didn't say anything else, you assume it's neutrally charged.
So if the question said that it isn't neutrally charged, how would they say?
Use
Bonding.
bonding. Yeah.
Sometimes electrons.
What? Electrons.
You're like this one, like constant. Sometimes it'll be more electrons plus electrons and protons.
Oh, the question will tell you in that way.
Oh, they just asking it's like without bonding.
Okay, let's let me wrap the answer in more
I got
really
better
understandable
way.
terms. Question is this.
What?
Okay, you don't know. Never
I'm
mind.
sorry, I don't.
Wait, what's that?
Oh,
Is this a compound or element? But okay,
correct.
because it's in a compound, so it means what? Like what May was trying to say, sodium is bonded to chlorine.
Okay.
Because there's a bond there, that means this guy is charged.
Positively or negatively?
Uh-huh. Good question. Good question.
So you give it the chlorine so that it has some electron.
Yes, so positive or negative?
So electrons.
Okay, come me, don't think so much. Yeah, right, Yeah, on the she's on the right track, but there's a shortcut to it. This is confirmed positive for one simple reason. Yes. Yeah, hope you know that.
So
You think so?
think I know that. No, I think I
You think about that?
so. Yes, I got that.
Let's ask me, Shang-Mei, how do you know sodium is a metal? Good. Actually, do you remember your staircase? Staircase, yes, no?
What?
Staircase.
Cool, that's like it.
I don't think that because it got staircase. It's not metals.
Yeah, good, eh? Good that you
If
remember.
I tell my classmates staircase, I don't really think they'll know it's staircase.
Come, actually, this is super important. It's super important. How about ladder? Have you heard about the ladder? Then what does your school use?
I know.
We don't focus much on like the periodic table, more of like the elements.
Mm-hmm.
We don't focus much on the arrangement. We focus more on the content.
Content,
Uh,
But the arrangement is super important too.
Yeah, I know the arrangement is important, but my teacher didn't teach me anything about that.
Okay.
Unless it's been a long time and I really forgot.
Come.
Oh my. Oh,
Come.
yay.
You are going to be writing all these sort of things all over the table sooner or later. But anyway, for now, we shall ignore that.
Is that in upper flat or?
No.
Huh?
No. No.
Then when is that?
Soon. Soon. Oh, you already have done it. Have you?
No.
Did they ask you to draw all sorts of rubbish on the table? No.
Have you?
Yeah.
But have you done?
Are you
Like on
supposed
the
to write
table.
anything?
Have you?
Oh, don't remember. Okay, come. I tell you what, I give you free copy of periodic table.
Every day you take an hour to get school. MRT. Wait, take bus. This one I take MRT.
I won't count this tree, because, because we only receive one. Then the final. So that means.
Come, you can write on this and bring it back. Okay, let's see. I'll give you some structure as to what you need to write. Hold on.
That's too messy.
Oh yeah, of course, it's super messy.
It's supposed to be messy.
Not if you can make it neat and organized. Okay, very simple. The first thing, come, May, draw your staircase. Since you already know it. Ashton, follow along.
Wait, like, where is the staircase supposed to be like? How do I identify where the staircase is?
Okay, follow along. I start from, hold on. Give me a moment to start the stylus. I start from this point. This point
Oh,
between boron and aluminum. Then go to the right, down, right, down, right, down, right, down, right, down. Okay, your copy is the newest version. Mine is the a bit slightly older version. So you can still see blanks there. Blanks.
you need that.
Yeah, of course. That is the staircase. Tell me what's important about the staircase. Okay, where are the matters? Yep. So Ashton, take note, important. Everything on the left are matters. Make sure you draw a staircase correctly. Yes, super important, super important. It will come in again and again and again.
But non-metal is called. Like, is it just non-metal or is there like a Pokemon?
No, just non-matters to do.
No.
Okay, May, how many elements are there? Okay, 118. Now, out of those 118, there are only 2 liquids at room temperature and pressure. There are only 2 liquids. Which are the 2 liquids? Oh, May, have you come across it? Okay, come Ashton. May I guess?
Okay. Temperature.
Yeah.
Wait, there are liquids that come at temperatures that can go or
Oh yeah, of course, if you change the temperature, then everything can become a liquid. Just only 2 elements.
I don't know.
Very good. It's used in balloons. All right.
Okay, wait, it's metal. Metal?
Okay, good question. There are 2 elements. One is metal, one is non-metal.
Okay.
Oh,
I don't
no,
know.
no, good guess, but no. Come, let me tell you the answer and to give out Ashton. There are 118 there. It's not easy to guess 2 of them. Okay, come right now. One is mercury.
What?
Mercury.
Oh, okay.
Have you seen mercury thermometers?
Yeah.
Is it a liquid inside?
Yeah.
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 Right. Yeah. Oh, I put L to stand for liquid. Now the other one is bromine. This one is not so obvious.
What is bromine?
What is bromine? Let me think. You don't really see it often in daily life though.
Yeah, but where can it be found?
Bromine, let me think. Bromine. You can go to the pharmacy to buy some. It helps to disinfect your water. Okay. Okay, now out of this 118, you have 12 gases only.
Gases.
No, just now you have 2 liquids, right?
Helium.
Oh, okay, good. Helium is of course a gas. Yeah, good.
What?
Neon.
Helium, okay.
Lithium.
Yeah.
Lithium, no.
I have not heard of lithium. Oh yeah, oxygen.
Oh yes, of course, good.
Nitrogen.
Good.
I don't know.
Carbon. Carbon.
Carbon?
No. No, what is carbon? Pure carbon. Pure carbon is like charcoal. Like charcoal. Black. Pure.
How do you see like identify which one are person?
I don't know. I don't know how many you have already guessed. Remember just now what was your other guess that you mentioned? The one I said used in balloons besides helium? Come, make sure you write this down. The lightest element. I really marked it down. Good.
No, it's actually.
Yes, it is.
What is fluorine?
Oh, fluorine. I must not tell you, fluorine is a gas too. It is a very hazardous gas.
Hazardous. As in it can kill you.
Yes, it can
Oh,
not just kill you, but it can react with many materials.
can what?
React with many materials. It can destroy a lot of different materials, not like plastics. It's very dangerous. You cannot contain it so easily. I'll give you a few more. Which one? Which one? Sorry. Number 15, phosphorus. No. How many do we have?
Okay, so we basically look at the non-metal side because gas is non-metal, right?
Yes, very smart.
So immediately we knock off like majority of the
Yes,
elements.
yes, very
So
smart.
we look at here.
Oh no. Come, I give you all the answers.
One isn't a gas.
Yeah.
Boron isn't a gas.
Yeah. Come, all the answers are on the screen.
I'm not gonna look it. Arsenic is not a gas.
Yeah.
Then for two, oh,
Tellurium is not a gas. Huh? What? Noble.
Oh, you haven't heard about noble gases? Okay, come. Better write down.
What's argon?
Argon is used in laptops.
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 Wait, what?
Laptops. Laptops. Do you think the laptop inside is just air? Or is it vacuum? No, not possible, right? There's something inside, right? Besides the matter and stuff, there's something inside, right? There's a gas inside. So argon.
So argon is a gas.
Come in, make sure you know this. All right, this whole column here. Column is 18 for you guys.
What is
Group 18 will be the
What is-
noble gases.
organism?
There's a new element discovered not long ago. I think just a few years back.
But what is it?
Not sure. It's so new that I hardly see it.
And chlorine, that's a gas?
Yes. Don't they use chlorine for warfare, to kill people? Don't you read about Second World War? They use chlorine gas as a weapon. Oh no. Alright, you read about it, sir. Okay, come. You should have 12 guesses. Do I have 12? 1, 2, 3, 4, 5, 6, 7. Yeah, I do. So yeah, it's very simple. Once you know your liquids and gases, all the others are solids.
Wait, sorry, noble gases is just like column.
Yes,
It,
yes, group 18.
what are noble gases?
Any information about them? Yeah.
Electrons.
Shells are fully filled.
Electron shell.
Okay, never mind, we'll touch on it very soon. Let me rephrase the answer. She's correct. No, she's correct.
Yeah, but I don't know what those are.
But what you need to know is that whole column of elements or noble gases are unreactive.
So they can't react to other elements.
Under normal conditions. Relatively unreactive compared to everything else.
Unreactive. It can be like, for example, why oxygen isn't a noble gas is because it can start fire.
Okay, that's one way to look at it, yeah. Okay. Ken, I'm giving you the bare minimum. Okay, let me see. Anything else I need to tell you about that? Yeah, a lot of other things you can write, but maybe not for today. Oh, yes, one more thing that you should know. Now, I want you to remember this few. This term here. Let me ask me what is meant by diatomic.
What? What did you say?
Diatomic.
As in Di and then atomic.
Yeah. Can't really get this look. Where they are. Diatomic. Okay, let me use the full phrase, diatomic molecules. What's the meaning, May? Okay, that means one molecule has only 2 atoms. Only 2.
Molecule only has 2 atoms.
Yeah.
So it's like the minimum.
Oh yeah, the smallest molecule you can find. No, but that's not my actual question. I mean, take note actually for you. They do use this term diatomic. Now, I want you to remember, Ashton, you as well. Hydrogen is diatomic. It doesn't like to be alone. it likes to be with another friend. So H2. Okay, so of course this is your H2 molecule. Okay, so hydrogen gas or hydrogen molecule is always H2. Okay, as far as your syllabus go. Now the others are N2. Okay, N doesn't like to be alone either. And you notice so far the gases, O2, of course. You should be familiar with O2. Guess what? S2. What else? Let me see whether I can zoom in. It's getting a bit messy. Well, you're waiting Cl2 as well. Yeah, Cl is here.
Sorry.
Yep. So remember chlorine is a gas?
So only gases are not like diatomic.
No, that's not entirely true. The whole last column of noble gases are all single atoms. All this,
gases.
yeah, I'm not finished yet. The reason is they are unreactive, so they do not need a friend. They exist by themselves.
So technically, because they are noble gases.
Yes. But I'm not done with diatomic molecules, Br2 as well. Even though it's a liquid, but it likes to have a friend around. I2 as well. Come, Ashton, your favorite element, iodine. And lastly, A2. S13. Now, theoretically, this guy here should be 2. This guy, this empty guy here.
You mean
should be diatomic.
then
Yeah, but very little is known about it, so I shall leave that out. And of course, it won't come up for you. I don't think it's going to come up by itself.
because it's very recent.
Yeah. There's so little known about it.
Because it's just discovered.
Yeah. Remember this here. Okay, if not, it's going to really screw up your day later on. It will.
Yes.
Okay, yeah, I think, yeah, that's the short version of it, even though I've could have written a lot more about that.
So written 10 times more.
But actually, for you, I want you especially to separate matters and non-matters.
That's like the basic.
Yeah, that's
the most basic.
the minimum you need to know.
Like the rock. Basic.
Okay, so next time don't tell me you don't know what the staircase is.
I probably wouldn't say I don't know.
You say you have forgotten. Okay, come. Let's go back here just to finish this now. Okay, make sure you Ashton get this correct as well. Oh, just I didn't finish with this.
Yeah, you didn't.
So I got 12 neutrons. How do I know? You take the larger number minus the smaller number, and then you get 12. That's how she got it. If this one you have to know. You have to know. You run the table, do you notice for sodium the larger number is 23? First column. Third row. Okay, so yeah, that's how she got all these numbers here. But what else was I trying to say? Okay, another way to look at it. The mass of proton is 1, right? Neutron, 1 also, right? So if I add them together, I get back the large number, 23. So yeah, in case you're asking why do you need to know all these masses, they tell you the mass of the whole atom. Take one charge. Okay. Number.
1. Positive 1, then 0.
-1 + 1 is 0. Actually, you didn't know that.
Yeah, no,
Oh, okay.
I told you last time.
Oh, okay. Wait for you. What else? Yep, that's the part about subatomic particles. Okay, what else was I going to go through? Bonding. No need to go through bonding today. Separation. Actually, let me just look at your screen. See anything else I need to tell you.
The electronic configuration, is it boring or is it just writing the numbers?
Oh, okay. That in your question, what did they say?
Draw the.
Draw the electronic configuration, is it? But it's quite confusing, no? Because some schools they use a different approach. Now, Hester, take note. This is the other thing you said you didn't know. Okay, I'm done. Let me erase that. Oh, there's something called electronic configuration. And electronic structure. Okay, come. Let's look at sodium again. Ashton, how many electrons does it have? Yeah, okay. Tell me, how do you write the electronic configuration?
How does that work?
How does that work? How do you know it's 2, 8, and 1?
Like we first shadow, like maximum is 2. Then from that onwards is the maximum is 8. Then you just get until you get the electron.
But let me also tell you something else. Now, look at sodium. Which row is it in?
First, 8.
No,
Sorry.
first column, but row? Third, third, you have to include this one as first.
Yeah.
So, third row on period 3 means what? It has 3 shells. So I draw 1, 2, 3. And of course, in the center is your nucleus. Me, what are inside the nucleus?
A proton and neutron.
Good. Okay, so these are stuck inside here. Which
And the electrons are around the nucleus.
Yes, good. But how do I know that? Notice there are 3 shells. This is shell 1, shell 2, and shell 3. But how do I know is this order? Because you have to remember first shell, maximum 2. Second shell, maximum 8. In case
How about the third?
but no need to go to the third, not for what else. First shell. First row is first shell. How many elements do you see there? 1,
8.
1 and 2. So that tells you there are only 2 electrons. Second row, how many do you see? It should be 8. So therefore, you know the second shell has 8 electrons max. Okay. So that's how she knows it's 2, 8, and 1. But I'm not done. If you're asked to draw the electronic structure, you should draw like this. Does your school follow the north, east, south, west?
What?
Oh, okay. So I start from north, then south, then east, then west. So start from north up to right. North. Down. But 2 max already, right? Then I go to the next shell. North, south, east, west. But I've only drawn 4. I need 8. So I go back to north again. Oh. Sorry, that was the wrong one.
Second shell.
Yeah. So north, south, east, west. Then I flip the second shelf. Then I go to the third shelf. Only one, so start from north. Okay, done. That's the electronic structure.
You need to do that in set two.
Check two, probably, possibly, most likely. Most likely no, it's because if you did do it last time for video, we asked the dates.
What about like how do you know whether it's like the maximum or
How do you know whether it's maximum?
is it always the maximum?
Okay, come. Me, draw for me, phosphorus. Meanwhile, Heston, think in your head, how would you want to draw phosphorus? Yep. Think in your head, how many shells does it have?
For sure, then.
Yep. No, like the inside is representing the nucleus. Yes. Okay, come, good, good.
Oh, I'm correct. Okay, 285,
Yeah.
correct?
So my suggestion is always good idea to write it out like this first before you draw it out, so that you won't make any mistake.
Wait, so basically at every like element the electronic configuration is always like maximum two per shell. It's always maximum two.
Yeah.
And second shell also always maximum eight.
Mm.
And then the last shell is just the remaining.
Yeah. Okay.
Okay.
However, notice that she used crosses, which is fine. So you either can use crosses or dots. Okay. It's up to you. But of course, later on you see a difference later on. But for now, I do want to be fine. Okay. We see anything else I need to tell you. The rest seems okay. Actually, I assume you're familiar with melting, boiling, freezing, condensation, right?
Yes.
All right, what's condensation?
Sensation is
Uh-huh.
sensation is when like
Mhm.
there's like a cold surface,
And
warm air,
and
and then like the water vapor you know around the cold surface in contact with that
cold surface.
cold surface, right?
And then
And then comes more water droplets, condenses into small water droplets.
okay. You get the idea. Okay, come. Let's start doing it.
Oh, we got 15 minutes to do this.
And you do not need to complete everything. I don't think you can.
Probably, probably really like also when you got on.
Oh, that's a standard kind of format.
Oh yeah, what's independent variable? I forgot what that is. I don't even know that about that. It's in
Independent variable is something that you can control, you want to change. And dependent variable is something you want to measure, you want to observe.
So the independent variable is something that we don't want to be,
Independent variable is something you want to change.
or then the dependent is something we don't want to be.
No, something that you want to observe. Because of changing the independent variable, you want to observe what happens to the dependent variable. Okay, note it down. Okay, variable itself is the quantity. That means it's time, not the units.
The function variable is a variable that's supposed to be kept in, right?
Yes. Oh, sure. Anything to ask, Ashton?
Wow.
Sorry. It's fine. Measured variable. Now, for this experiment, what do you need to measure?
Time being
Yeah. So how do you measure time? Yeah, that's the official answer. That's what you use in the lab, right?
What does the measure like a unit use?
No. Time is the variable. It's measured. So you should write time then. So, and right for you, of course, I hope you know how to spell everything. So ask yourself, what else do you need to measure? Look at the experiment. What do you need to measure?
Oh, we.
Uh-huh.
Weighing machine. I forgot the name.
Oh, okay.
Forgetting this one.
That's okay. You just remember along the way. What's the variable?
Mass.
Good. So you use your weighing balance or weighing scale, depending on your school. But please try to remember. You will see this again.
I asked May just now the same question. She said she only know one.
Which is? Oh,
She didn't
really?
tell me which one she know.
Okay. Actually, there's still one more, but the question only asked for two.
The heights.
Yeah. How do you measure the height? Oh, okay. That's still okay. But look at the height. What's the value of the height?
Meter.
So it's 1 meter, right? So therefore, I can use a meter rule or meter ruler.
Is there a difference between meter ruler and meter ruler?
Meter ruler means that it's really 1 meter long. Otherwise, it'd be your short rulers that you see. Okay, so if you want to impress your teacher, then you write meter rule.
See some brain use than impress me.
Oh, okay.
But if I really do remember it, I'll just write it down.
Yeah. Otherwise, just
Better
write
lah.
ruler. Question 2 is very standard. Try to get it
wait.
correct.
For P, right, if number of neutrons is. Wait, did they say electric charge or?
No, okay, first thing. Yes, it is.
Zero, right?
Yes.
What is neutron?
That is not the reason.
Because we want
Okay, come. Look at it. What's the atomic number?
atomic number.
It tells you the number of protons. Which is the smaller number on your periodic table. Actually, make sure you can identify the smaller number and the larger number. On the other hand, your mass number is the larger number on your periodic table. And what does that tell you? It tells you the number of
Neutrons? No, sorry, protons? Yeah, neutron, okay.
plus proton.
Proton, okay, so my answers were correct.
Yeah, so there's 0. Because you notice 1 minus 1 gives you 0. Can you see this?
It's a bit confusing.
Mhm.
Smaller number. Starting to lose focus here because I'm getting tired.
Yeah, you need to get a bubble tea. No, when you minus something, I mean, at least for normal maths, right, it's always the larger minus smaller number, right? So the larger minus the smaller will give you the number of neutrons. Let me write down for you, but maybe you should write it down somewhere. I mean, you feel free to write it in your notebook as well. This is going to be important. Okay, so number of neutrons is goes to larger number minus the smaller number in your periodic table. This is important, really important.
The answer for 1D is like stopwatch and mini scale. Oh, that is really cool. That's not the one.
Yes, go and freshen yourself.
Need to find it. And then it does like lowest common multiple, which is the we need to find what is the lowest common multiple for this. We can do it. Not lowest common multiple, but in the right. It is where. Oh, is and what is and what do you think? So anything about you, but what do you think? Leads to the excitement. We need to do I change yourself. I'm going. And then this rule is of one can be invited now. We can have a few items so anything. For I think just as Lawrence's probably Then for the this is in time of tree just thank you for
I mean, the rest, no problems. Oh, meaning you don't know how to do them.
I haven't. I found this one, so I'm gonna go back to it now.
Oh, okay.
I cannot answer for question.
Question 3. Oh, okay. This is not a common question. I think for lower sec, they just need you to talk about science. Science. Okay. Here, do you want the filtrate or the residue? Imagine this is a filter. Yeah, but what happens to the residue? They get stuck behind, right? Because they are too big to pass through these 2 layers. But of course, you can also mention, obviously, the holes in the stones are larger than the holes in the sand. So the stones, you capture the larger residue or larger impurities, whereas the sand, you capture the smaller impurities. Okay, so for lower set, that's all you need to say. Your school tests you on reverse osmosis. No. But I'm sure they've taught that it is taught within the lesson. Oh, yes, but what is so special about reverse osmosis is that filter. That filter is normally they don't use the term filter. Instead, they use this word. Yeah, membrane or semi-permeable membrane. But what is so special about this membrane is the holes are small enough to capture solids, no, like sodium and chloride, no. So that is so special. They can capture very, very small solids, and only water can pass through.
is they're small enough to pass through the partially permeable membrane.
For this question, yeah.
But I feel like it's not enough. It's not sure.
Why only chemical molecules and dissolves are able to pass through partially permeable membrane? Well, of course, one thing you can add on is basically your partially permeable membrane acts as a filter, and the holes are big enough such that the molecules and dissolved salts can pass through. Ashton, try to complete this table. I give you a few more hints. Mass number. Basically, you get number of protons plus number of neutrons. Number of protons is from here, 3. Neutrons is from here, 4. So now you have your answer. Same thing here. Protons, 7. 7. Neutrons, 8. Okay. How about this number of electrons? Just now we mentioned on the whiteboard. Notice this one? Same. 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 Yep. This one shouldn't be a problem. Yep.
18.
This one, yes, good. Okay, yeah, you should be able to fill in.
How many shell meaning the third shell?
That depends, because if there's only 2 shells, then the outermost is the second shell. So you have to write the electronic configuration.
Enter the shells. When there's one shell, it's like 0.
How many electrons? You have to check how many electrons does it have. Then you add 2, 8. If you still have some more number, then it's 2 something. That means you have 3 shells.
Well, there's only one electron.
Then it's only 1 shell. Then that's the outermost shell already. You let me know if you need help, Ashton.
How do you do BI?
What do I mean?
How do you do BI?
With 8 electrons, come, Ashton. This one, look at P. How's the electronic configuration like? Only 1 electron, no? So I just write 1, 3,
None of them got
1.
8. None got 8.
There's one that has 8 though. Come, Ashton, look at the last one. You have how many electrons? 18, right? So 2, comma, 8, comma.
Oh, like that.
Yeah, that's why you get 8. Okay, actually, yeah.
Yeah,
It's not difficult.
I thought it was like number of electron mean just the number and then.
Oh no.
I didn't know they were talking about configuration. Oh, because it's the outermost shell. So
Yeah.
they're already talking about configuration.
Yeah.
Okay, so it's like a trick question.
Yeah. So you have to figure out. That's what you need to do.
You gotta look at it personally.
Yeah, they won't tell you directly. You have to do that. Water vapor. Just water. H2O.
The H in H2O is hydrogen.
Mm.
How do you know what are the metallic elements? Like from this table itself.
You can't. Actually, you can, but it won't be
Easy.
accurate. The best is they probably give you a periodic table.
No,
No, it's provided.
they ask which are metallic elements from the table itself.
Yeah, but this is actually part of a test, and in the test you're given the periodic table, which I didn't print for you. I mean, as part of the test. So what should you look at? Specifically,
Okay, so you're telling me we need to look at the number.
which number? Tom Ashton, the safest way is to look at this atomic number,
So atomic number is the bigger one, right?
smaller one,
Oh,
because that identifies the elements, not the bigger number. Remember that the smaller number identifies the element. So check out what they are: P, Q, R, S, T, U. P is obviously hydrogen.
you has to come.
Okay, then
Oh, yeah, it is.
you better figure out all the rest. How many need help?
Wait, so is hydrogen is a metallic element?
So where's your staircase?
Not even part of the staircase.
Yes, good question. Main is hydrogen a metallic element? No.
How
That
do you
is it is.
Okay, he said.
Oh, okay, but that doesn't tell you much. A metal can be a gas too. But Heston, you ought to know hydrogen is by itself right in the middle. So they're telling you that even though it's on the left-hand side, but it's not counted as a metal.
That makes no sense.
Ruler. Okay,
Oh
sure.
my God, don't need.
No, think about it. Because if it's a metal, where should it be located? On the periodic table. Where should hydrogen be located?
On the left side.
Yeah, and
Basically, it's the majority of the table.
look at hydrogen is 1. By right, 1 should be right here, no? but it's not right there. The reason is they want to make it very clear it's not a matter, so they put it somewhere in the center.
Why can't you put it here? Why can't you put it with the vectors?
Well, that's a good point, but they don't want it to fall under any of the groups over here either.
Why can't you put it close, like directly next then? Why do you have to put it?
But anyway, you better know it's not a matter.
Well, the table makes absolutely no sense.
You better make sense of it. Okay, or your life is going to suffer for the next 3 years. Yeah, no problem. Which one? Which one? This one. One improvement. Okay, this one is, they don't ask this very often, but if you remember when they introduced that part about water filter, did they have something else that's not drawn here?
Oh yeah, I got a question about the periodic table.
Okay, hold on, let me answer her first. I remember, right? Do you come across this term called activated charcoal?
The charcoal.
No.
As in reactive charcoal.
Yeah, reactive charcoal.
Isn't charcoal already reactive?
They make it even more reactive. Anyway, she's asking about this question.
Oh, are you so far in?
Well, she remembers her stuff. Okay, come. Maybe Ashton, you can listen up as well. Look at this. It's supposed to act as a filter, right? But stones and sand, do you think they are good enough to make clean water coming out here? No, right?
No.
So,
No way.
yeah, so what is not removed by this filter? Oh, by the way, this is called sand filter, even though you don't have to know the term.
I thought it was sandpaper.
Okay, it's a
Or
sand
coffee
filter.
filter. Coffee paper.
What can't it remove? I'll give you an important one. There are lots of things it cannot remove, but it cannot remove germs. All right, you are not going to drink the water here, no? No way. No way.
Why?
Because the germs are still in the water. You cannot use sand to remove germs. So how to make it better? Well, actually there are many suggestions. One of them is to improve the quality of filtration. I'll give you, what's the easy one for you to understand? Activated charcoal. So I can put a layer activated charcoal here.
What even is activated charcoal?
Oh, you haven't seen it before.
What does it have? What does it contain to make it activated charcoal?
Wow. Hold on, let me just grab this.
No,
Do you even know how it looks like activated charcoal?
it's not black, that's also right.
Of course it's black.
You have activated charcoal.
I used to have it, but then I still it's maybe one color. Those color is yellow and then the other one is the false. Boss and boss and
Yeah. Yeah,
Why is it in the
that's how it looks like.
what? It's a pill.
Oh yeah, it's a pill. It's for you to eat if you want.
Can eat it.
Yes. Why? Yeah, why?
So what is it for?
But let's answer your first question.
Oh, yeah.
What makes it activated? May I assume you've seen charcoal before? But normal charcoal is not good enough. So what happens is they use normal charcoal and heat it up until normal charcoal. They heat it up and it expands so that there are a lot of pores inside, a lot of holes. And because there are a lot of holes, it has a lot of surface area. And this surface area can capture impurities, unwanted stuff,
Like
poisons, germs to a certain extent, yes. So therefore, if you have a stomach ache, diarrhea, you eat this in, it's going to absorb those toxins in your stomach and intestines, including some germs, because of the large surface area. So it helps to clear your digestive system. Make sense? Okay, but there are of course other answers. I just give you the simple one. So just add a layer activated charcoal in between. Ashton, maybe you should write this down. No, no need. Coca-Cola. Oh, this one is a difficult question. This one need to test your knowledge of several different things.
So
Laws are. Now come, at least get the basics correct.
sign.
Come, Ashton, maybe you tried this before. Have you tried boiling Coca-Cola until it cannot boil any further?
All the water. Bye.
Yeah, so
Inside the pot.
where's that? Where's the thing?
The powder.
What for?
Whatever you call it. The remainings.
Okay, come.
The
Why?
solid-
Why is Coca-Cola bad for your health?
Because got a lot of sugar.
That is the key. It
Yeah.
contains lots of sugar. So you keep boiling until no more water and you keep heating the sugar. What is left? Your were you the one who used the word caramelize? Yeah, so basically your sugar caramelized into a black mass. It's not easy. So basically,
Science is not easy.
but it's interesting.
Yes, that's why I like and hate science at the same time.
Oh, good for you.
Is that good?
It's a love-hate affair.
Farming right now.
But it's so relatable, don't you think, to daily life?
Only thing science can't relate to is mentality.
You can, if you study psychology. But you can skip this question if you want to, Ashton. Most likely your school will not ask it, but your school can ask difficult questions as well, no? I've seen them before.
You know my school.
Yeah, OPSS, right?
I got tell you.
Your mom has told me. They asked about reverse osmosis before. Because I got another boy here in Sec 4 from your school. Who I don't think you know him.
No, please tell me the name. I want to see what I know.
You know a boy called Jing Jie?
Jing or Jing?
Jing.
Jing or Jing?
Jing.
Jing. I think I know. Think so.
Okay, let's use May's words, caramelize. Like residue. Let's use some scientific words to impress your teachers. But Ashton, feel free to skip this. You can bet that you're not bet lah. Hope that your school won't ask this.
Oh yeah, I had a question about periodic table.
Mm-hmm.
Oh right, why is it some elements don't have the formula thing? Like like the sign, like the HF whatsoever thing.
What? Like what? What substance doesn't have?
Like this thing, like this, like why is it this thing don't have
Oh,
the
you don't know.
yeah,
You better know. You better know. Maybe. Let's check with me.
I don't know what crystallization is. I obviously don't know why it's like that.
Okay. Wait, just pause a moment. Take a look at periodic table. Actually, let's ask a pretty good question.
Oh.
Okay, so make sure you get good results.
I can't.
Look at here. What is this?
Yeah, why?
What
Why?
is this?
And then why the number? Why is there two numbers at the top but no number at the bottom? And then why is it like from one number to another?
Yes. I mean,
Why
you
is
have the answer.
a wide range?
Yes. Yes, good. Good. She knows the answer. Because
Yeah.
she does, though she didn't answer that fully though. Do you notice the word here is exactly the same word here? So in other words, this whole row fits into that small square there.
This small square consists of many other elements.
Yes.
So it's an element that has a mixture of other elements.
It's not an element, just that this small square consists of many, many different elements. Do you notice there's a jump in the number here from 56 to 72? What happened to all the numbers in between? They are all here. All right. Again, make sure you realize the bottom is applicable as well. This whole bottom square contains the elements from this whole row here, from the second row, I mean. Why? For the simple reason, they have the rules no longer apply. Remember, I didn't answer your question, right? First shell has 2 electrons. Second shell has max 8 electrons, right? But third shell is not 8, no. Fourth shell is not 8 also, no.
There's a whole shell.
Of course, how many shells are there? Count.
That's all.
How many shells are there?
Oh, okay.
How do you know how many shells? Yeah. Do you notice there are 6 shells? Actually, it's not 6 shells. Come. 1.
Wait, how do you know what's the maximum number of the third shell?
Okay, let's go one at a time first. Do you notice how many rows there are in the periodic table? 1, 2, 3, 4.
5, 6, 7,
6.
8, 9.
No, those 2 are not counted. These 2 are subsumed into the 6 and 7 shells. So you have a max of 7 shells. Alright, first shells, how many electrons? Only 2. Second, 8. Third is no longer 8, no? It's 18, no?
Huh?
No need to know. Fourth shell, how many? 32, no? Fifth shell, 64, no? Okay, so because of the increasing number of electrons, you can't just fit into this single square anymore.
Know about 6 shells.
Next shell, and then you keep on adding and adding and adding.
Adding like what?
But actually, you're right. Sorry, even though on paper it seems it has 7 shells, but actually the max is 6 shells. But no need to know the reason why.
No, but I want to.
Oh, yeah, but it's not going to come out.
Please, I just want to. I'm not gonna write it down. I'm not gonna memorize it.
It's because of how the electrons are arranged. It's no longer the 28888 rule, no? It's 28 something rule, no?
2, 8, and then you're gonna put.
Yeah, bigger number rule. Huh?
Oh, for step 2, is it possible that the background configuration is the electronic configuration will be like that shell?
No, they'll just give you max
Opposite?
opposite, no. Opposite maximum, they will test you up to calcium already.
Up to what?
Calcium. So you only need to know how to draw up to
3 shells.
calcium. Yeah.
You just need to know the 3 shells for secondary school.
Yeah. Up to calcium, calcium is in the 4th shell already.
Oh, calcium is 4 shells.
Yeah, where's calcium?
40.
40 is what? 1, 2, 3, 4. 4th shell. That's all. Okay. Any final questions? All right. If not, bring this along next week. Then we go through. You have to. Yeah, you better go home and finish. At least finish first 4 questions. Oh, don't worry. Concentrate on the love part of science.
Hope I can.
Yeah. Try to ignore the head part. Okay, bye.
Sure.
Okay, sure. Bye.
My next is the iMatter.
Let me see. Do you know it's Clarence? Probably not.
Clearance
Yeah, you good
from
friend.
from O2.
Is he in O2 now?
Yeah.
Is he in O2 now?
I think maybe I'm APC.
Yeah, yeah, yeah.
I think all the details here.
Yeah.
Oh, okay. That's a lot of questions in class.
Oh, okay. But did you prepare the materials for me?
Yeah, I'm doing it.
Oh, okay, okay.
Ciao.
I mean, periodic table.
It's physics.
Ah, this physics. No. This was the previous class.
Was it the one that's like four?
Ah,
It's
that's good.
in
Minus. Okay.
oh, this one looks very,
Very.
very
What?
worth it. But is it worth it?
It's quite nice, but I think it's also quite unhealthy because they use a lot of salt.
Use energy.
Yeah, I'm quite sure they do.
Oh, that tastes so nice. If I just order 8 pork belly, wouldn't it be very worth it for myself?
Which one?
This drink, 8 pork belly, 11.81.
Yeah, yeah, yeah. You should order all the high value meat. Yeah.
Horrible.
Oh, not bad also.
So I for.
Mm.
Can later I got
You later. Oh, okay. I don't think it's very crowded, right? I think should be okay. Now the crowd has worn down. When it first started, it was crowded.
right.
Mm. Hey, Ning-Ting, do you see this around your table?
Over there.
Oh, okay, it's behind.
Like
Activated charcoal.
the medical box.
Yeah, it's a medicine as well.
That's all worth it. It's all veggies.
Mm.
I look it up like
No, go for the meat. Yeah, you should try. You should try. I tried it a few times already.
But after that it's not healthy.
Not healthy, yeah, so only a few times.
Okay.
No,
Oh,
but yeah,
finish.
yeah, I think they haven't. You mean you're finished? Oh, yes, before I forget, let me pause this first.
It's not coming anymore.